Hello team, welcome back. And today we will see a lab on deployments in Kubernetes. We will see the labs, how we can create deployment, how we can upgrade the deployment, and how we can perform another use case on deployments. So before starting the deployment execution, we will understand the deployment manifest. So here I have created a deployment manifest, and you can see the API version for this deployment manifest is apps v1. The kind is deployment, and here we are defining the metadata for this deployment. The name of my deployment will be chef server. The labels, I'm attaching a single label with my deployment app chef. Then we are defining the specification, and the specification we are defining the replicas that is similar to the replica set and replication controller. Within the selector we are defining the match labels, and it will match a label on the pods. Label is apps chef server. This is the label which will be matched on the pods. Over here we are defining the template for the pods. Within the templates we are defining metadata and labels, and you can see the pod label is again app chef server. Please make sure this label and this label, they must be same. If they are not matching, if the selector label and the pod label is not matching, then definitely you will face the issue. Then we are defining the specification, and we are defining two containers. This is my first container where the container name is chef server. The image I'm using chef dk colon 4.9. How we can select that image, we will look into it shortly. We are defining the port on which particular port this image will execute, and port is 8080. Then we are defining a execution shell command, right? Hyphen c for passing the command, and this shell command will just print this particular thing and sleep for 300 seconds. And after the chef server container, I'm defining another container within the same pod, and the name of my container is Ubuntu, and this is using Ubuntu 18.04 image, again executing on port 8080, and this is the command which will execute on this container. So this is a deployment manifest we are going to use to spin up the deployment. Now first let's check this image, which is a chef image and Ubuntu image, how we are getting these specific image number. So we will go to the browser, and we will go to the Docker Hub. So we will type Docker Hub, click the hub.docker.com, and here search for the chef. So we are getting the chef DK image. Let's open this, and within the tags you will get the specific image. So we are consuming 4.9. These are the images 4.9, 3.1416, and 4.9.8, which is present for the chef, and we are using this particular image. Similarly, if we will open this in a new tab and we will search for the Ubuntu, so here we are getting the Ubuntu, and see we are using 18.04 image. Other images which is available with Ubuntu is 20.04 and 20.10 and other few images. Now we will go to the terminal and create a connection with my Kubernetes cluster. So here we created the connection with my Kubernetes machine, and we are in the deployments directory. Over here we will create a file vi deployments.yaml. Hit enter, go to the insert mode, and we will copy this manifest and paste it here. Now I will close this. So you can see we are using chef image 4.9 and Ubuntu image 18.04. We have defined the three replicas. To create the deployment, we will execute kubectl apply -f deployments.yaml. Hit enter, and see we are getting deployments apps chef server is created. Let's get the status of this deployment. So kubectl get and provide your deployment name. So we can see that the deployment is in the ready state. It is expecting the three replicas. Out of three are running, and they all are up to date and all are available. If you want to check the rollout status of your deployment, you can execute command kubectl rollout status and your deployment name. If the deployment is in progress, you will get the in progress status over here, and as we can see the deployment is successfully created. So we are getting deployment, your deployment name successfully rolled out. Let's describe this deployment. So I will execute kubectl describe and provide the deployment name. Over here we are getting the details, the name of my deployment, Then over here we are getting the replicas, and 3 replicas are desired state, 3 updated, total 3, and 3 available. 0 replicas are unavailable. And we are also getting one property called rolling update strategy, which is saying 25% max unavailable, 25% max search. We will talk about it shortly, that what is rolling update strategy and what is the meaning of 25% unavailable and search. Here we are getting the pods which is running as a part of this deployment, and the label of the pod is app equals to Ceph server. Within the pod we are running two containers. So this is the first container, right? And here is the second container, which is a Ubuntu based container. So within the first container you can see this is a Chef server. The image we are using Chef DK 4.9, and we are also getting the commands. The second container is Ubuntu container, and image we are using Ubuntu 18.04 and the command. If you will scroll a bit, in the end it is saying, then in the events it is saying scaled up replica set Chef server, then some random id to 3. What does it mean? So I told you that deployment is a higher level abstraction layer of the replica set, and deployment will directly manage the replica set and container. So ideally we just created the deployment, we have not created the replica set. But if you will execute a command kubectl get rs, which is mean replica set, you can see a replica set is already running, and that replica set name is starting with my deployment name and then some random id. The desired state is again matching with my deployment. So basically this replica is being created by my deployment. So the structure is like this. Here we have the top level, and at this particular level we have the deployment, and here we have the deployment. This deployment is creating a replica set, and these replica set will have the further pods. You can have the n number of pods as defined in the replica set. So we created the deployment created the replica set. Now if you will execute a command to get the number of pods, let's see what we will get. So we are executing command kubectl get pods hyphen hyphen show labels, and see 3 pods are running over here, and every pod id is starting with the replica set name. See, then we have some random ids. And one more thing, each pod is running 2 containers, right? So this is the complete structure. We are executing the deployment is executing the replica set, and replica set is managing the number of pod which is running as a part of deployment. So I hope you get the basic concept that how Kubernetes is basically maintaining the multiple instances of your application. And if you want to maintain the multiple instances of your application, then deployment is the correct Kubernetes object for you. So I'm closing this lab over here. In the coming lab, I will show you what are the other benefits deployment provide over the replica set.